Hello everyone! We meet again to learn another important part of photovoltaic battery system that is close to people's daily life, household connection. What are the main purposes in this session? First, know the good and the bad household connection. Second, know how to make safe household connection. And third, know how to educate people on efficient energy usage. It is very important to know a good household connection, especially concerning safety, because most of the time, the consumers are unfamiliar with electricity, so they must be protected and educated. There are some possible safety risks to be prevented by installing safe household connection. For example, electrocution, fire, and short circuit or broken electronic appliances. Electrocution is caused by direct contact with active open wire. Active wire means there is electric current through the wire. Contact with open wire can be caused by failure in cable insulation. Moreover, wet material or metal can conduct the electricity if touched by the wire. Electrocution can kill. The next risk is fire that is caused by high temperature or spark of electricity. High temperature on elements can be caused by high home appliance load to specific connection, while electric sparks can be caused by bad connection between conductors. If the house is made of wood or if the connections are close to flammable materials, then fire might happen. It can kill. The last risk is the breakdown to low voltage or voltage drop on electrical appliances that use electric motors, such as fridge, ballast-equipped lamps, or pumps. It is therefore very important to keep the household connection in good condition to avoid voltage drop. In this session, we are going to answer the following questions. What are the common components in service connection? How to install a service connection according to standards? What are the metering system in household? How to install a household electrical system? How to calculate maximum number of household connection? How to calculate potential energy usage? How to educate people on energy conservation and energy efficiency? And how to calculate energy consumption. To evaluate your understanding, do not forget to spare little time to take quiz in the end of the session. A service connection is a group of components that includes wires connecting household connection with low voltage distribution network. A service connection usually consists of service drop and service panel, including energy meter and protection device. So basically, there are three main components: distribution network, service drop, and service panel. Let us learn each of the components. Service drop is a cable connecting low voltage distribution network to the energy meter using connector tab. A service drop functions to convey the electricity service to houses. The cable of a service drop is connected to a dot and clamp at both ends to make sure that the cable has enough tension. A service drop must follow some best practices, such as all service drop installations must follow the strict safety standards of local utility in making electricity service connection. Limit the voltage drop to maximum of 1% by using correct cable size and length. A cable that is too long or too thin will increase the voltage drop due to higher impedance. At minimum, use a 10 mm squared cable for a service drop, although there is possibility of low energy usage at the houses with NFEAX 2 × 10 mm squared. Always use service dot and clamp on both sides to hold the cable and adjust the cable tension. You must consider all options for safety. Do not use non-standard components such as cable ties for service drop. Hang those cables properly to ensure safety and good service. After service drop, the next important thing in household connection is service panel. Service panel functions to connect household electrical appliances to the electricity service from the grid. It consists of some subcomponents such as energy meter that usually comprises of energy limiter, mini circuit breaker or MCB, and grounding. In the example, we are using energy limiter system. It is also possible to use other systems such as smart meters. However, the safety principles are the same. Energy limiter is used to limit daily energy usage. In a PV battery system, this is important because we do not want battery to be over-discharged if usage is not limited. Battery is expensive and must be protected for longer operation time. MCBs are used to protect the household connection from short connection that may cause fire, which is particularly dangerous if the houses are made of wooden material. Grounding is important especially to protect household connection and household electrical appliances from lightning strike. Energy meter is installed as subcomponent of service connection. To install energy meter, we need to consider environmental and ease of access aspects. These are how to comply with those two aspects. Energy meter and MCB must be protected from harsh environment conditions by being installed in a protection box or enclosure that has minimum IP45 rating. The box or enclosure must be installed under a roof to protect it from rain and direct sunlight. You must consider higher rating protection, especially in area close to sea, in which the air is salty and can cause the components to rust. For easy access, the box must be installed at the height of 150 to 200 cm. If installed at higher height, it will be hard to be checked without using ladder. If installed at lower height, children may reach it and possibly cause safety issues. Wire installation must be neat and good too. All in all, consider weather and environment protection as well as right height to the meter installation. Energy limiter and MCB must be installed properly. Not installing the limiter or MCB can cause the following issues. Energy limiter limits the use of energy per customer and so implements equal access to energy. It will be unjust if access is not limited, because those who can afford to buy more appliances will use more. Energy limiter also protects the system from exhaustion. If energy is used too much, the system will be exhausted and battery can break due to deep discharge. MCB protects the indoor installations from short circuit that can cause fire. In this example, the first picture shows the meter is installed at too high location, that is 3 meters from the ground, and not protected in a box and not under a roof. The second picture is an improvement from the first one. The meter is boxed, installed at normal height and under a roof. This way, the meter can be inspected easily by the owner or the operator. In this example, the first picture shows installation that can be improved. The box doesn't have IP rating, that means it cannot protect the meter from severe weather condition. The second picture shows the meter is installed with IP45 enclosure and it is sealed well. The MCB can also be accessed by the house owner. The installation in second picture is much better. Please note that for areas in which salt substance in the air is high, for example areas close to the sea, the protection box or enclosure must be strong enough to withhold the salty air. IP rating 45 or higher is needed to ensure this. MCB or mini circuit breaker is a small yet important component for safety and sustainability of the PV system. A bypass connection means full access to PV system that can cause draining of energy in the system and jeopardize the long-term operation of PV system. Battery can break because of this. So MCB and the meter are important. Always try to spare at least 10% more of MCBs for a new site. To calculate the right MCB specification, we must know how many new connections can be made. See the step-by-step diagram. We are using the power rating method for easy calculation. First, it is to determine the capacity of the PV system, number of connections as planned, the rating of MCB, for example 1 ampere or 2 amperes. Then calculate the maximum number of connections available for the system. Lastly, calculate the available additional connections. MCB rating selection also determines the different classes of connections, especially for productive use of energy. Otherwise, by using the energy method, we must determine the daily quota, then assume or get the data on average solar irradiation at the location and the losses of the system. Usually, the energy method will result in more connections, so it is safer to use the power rating method. This picture shows some best practices of MCB installation. The first thing that you must consider is safety, and the second is about tampering. Make sure the MCB cannot be easily tampered or bypassed. Use the rating for the system, not higher rating. Make sure the installation is safe and neat. Household cabling starts from the meter or MCB and into the house. It can include sockets for lamps, outlets, switches, cables, and grounding. The same principle still applies. Safety. You must use good quality components for household cabling. Make sure that all connections are made safely and properly to prevent risks of fire or electrocution. By knowing the risk and requirement to reduce the risk, we can take steps to implement household cabling. Installation must follow IEC 60364 or local standard. Installation must be safe for users and professionally checked during commissioning. Sample checking must be done to validate result of commissioning. All electrical appliances that need grounding or in general using metal box must be grounded. Grounded appliances reduce the amount of electrical current going through the body in the case of electrocution. Use residual current device to protect users from electrocution, as a prevention is the live conductor is touched. Use double insulated appliances to prevent leaks at connection housings. Local operators must check the cabling and grounding installations of each houses regularly. It is recommended to do the check twice a year. Here are some best practices for house wiring. Proper grounding will make household connections safer. Appliances without proper IP rating must not be installed outdoor. Bad connections can create electric arc that may cause heat and fire. Never connect wires directly to power outlet. Use plugs with proper quality. Wires must be properly clamped to solid foundation and never let them hang loose. Always use wires with double insulation such as NYM or NYY types. Use recourse cables for phase, neutral, and safety conductor with diameter of minimum 1.5 mm². NYM cable with 1.5 mm² diameter can conduct 18 amperes at 30 degrees Celsius. Cables must be installed inside the cable conduit to protect cable insulation material from damage. PVC pipes or flexible conduit can be used. If single insulation cable is used, the installation must use cable conduit. Lamps must be installed in a threaded lamp holder and not hanging. Power outlet sockets must have grounding terminal that is connected to grounding cables for safety. For safety reasons, switches and outlets must be installed at minimum 150 centimeters from the ground. Let us look at this example of good and bad wiring. The first picture shows the lamp holder is not installed right under the roof. Since it is not IP rated, heavy rain can cause damage. All appliances or components that are not rated for outdoor use and cannot withstand harsh climate or environment must not be installed outdoor. The second picture shows the lamp holder is installed right under the roof. It is safer, although the component is not IP rated because it is protected only by the roof. To fix it, the lamp and its holder must be installed on a platform that is protected under the roof. Here is another example on wiring. The first picture shows bad connection because the wiring is not protected inside connection box. You will have to use twisted cable connector. The second picture shows a neat proper cable connection. You can see the proper connection boxes and cables are clamped to the wall properly. You must pay attention to connect two or more conductors as they must be twisted to each other and fastened using twisted cable connector. Avoid using electrical tapes to cover the connection since they are thin and can easily be damaged. Live wire can electrocute. Connection junction boxes must be available. Voltage at the farthest point of the grid must not be 10% lower or 5% higher than nominal voltage. It means the voltage must be between 207 volt to 241 volt for nominal voltage of 230 volt, or between 198 volt to 230 volt for nominal voltage of 220 volt. Voltage drop is not allowed because lower voltage means higher current that may damage the cables. Voltage drop can also make the MCB trip due to sudden increase of current. Voltage drop can shorten the lifetime of motors in electrical appliances. In case of voltage drop, it is important to always check proper cabling from the grid to the household connection to improve the quality of electricity supplied. Now, we are arrived at the usage of energy section. It is important to understand the limitation of a PV system so that usage can be maximized and the PV system can give maximum impact to the community. It is also important to consider efficient usage of energy and using energy-efficient appliances. Usage of energy must not only for lighting or entertainment, but also productive activities. It is very important to educate users about limitation of PV system. They need to understand how good energy utilization is. With proper usage, the system will last longer and provide better service to community. The first part of energy usage is productive use of energy. Productive use of energy is an important part for a PV mini-grid sustainability in improving its ability to benefit users or improve the financial situation of PV system management. However, you must consider some important points. You must understand the operational characteristic of appliances. You cannot just connect any appliances to the grid. A load with maximum of 1000 watt can be connected to one-phase connection, while more than that needs three-phase connection. You must consider the system ability to provide power. You cannot just start any productive use. Calculate carefully and consult with others about tariff and other regulations. Consider the main purpose of PV system is to provide lighting, and so nighttime productive activities are not recommended. Productive use must be maximized during daytime, especially if production machines are used. Soft starter can be installed for motors. The second part of energy use is energy conservation. You must conserve energy to make sure that energy is not wasted and the system can last longer, especially the battery. Conserving energy, in principle, is to use energy properly and not wasting it. For example, lighting for study activity, electricity for production, lighting for streets at night, and etc. One example for energy wasting is to keep the lights on during daylight or when no one in the room. There are many ways to do energy conservation, but the key is education to users. To optimally use the energy, you can use energy-efficient appliances. This means you can get the same service with lower energy consumption. For example, using LED lamps and LED TVs is more efficient than using incandescent lamps and CRT TVs. Energy-efficient appliances are usually a bit more expensive to purchase, but in the long term, it will be cheaper to operate. They usually last longer too. To be noted, LED lamps are now pretty common and quite cheap to get. So, since beginning, it is recommended to start using energy-efficient appliances. The comparison table shows LED lamps emit more lights, operate longer, and have lower operational cost. The purchase cost is also not far higher compared to normal fluorescent lamps. Another example of energy-efficient appliance is TV. The left picture shows CRT TV that although has lower purchase cost, it is less efficient than LCS TV. To conserve energy, LED TV is recommended as it consumes lower energy, although has higher purchase cost. Thank you for keeping up so far. Now we are near to the end of this session. But before ending it, you need to do a quiz